Hello everyone, this is section 3.9. Um, so again, before we start this section, just want to remind you guys about the exam. So this is exam 2, not exam 1. So the exam 2 is, I think you all know that it's Thursday during the regular class time, which is 5:30 p.m. And this one's going to cover from section 2.3 till section 3.5. All right, so 3.5 I covered that last Thursday. Right, so starting from section 2.3, basically whatever I covered, here, um, from here till here. Yeah. So yeah, this is going to be an exam 2, and this time you guys will be getting 1 hour 30 minutes total. All right, so you have to, so that means you have to submit your work by 7 p.m. Okay, yeah, 1 hour 30 minutes. Yeah, 7 p.m. All right, so now this is, like I said, this is section 3.9. So this section is about antiderivatives, or I say antiderivative. Anti. I don't know which one is correct pronunciation, but I normally say antiderivative. Okay, so the idea is basically, well, when you say a derivative, or let's say a function, something like this is given, x squared, and when we take the derivative of this, then this is going to be 2x to the power 2 minus 1, or just 2x, right? So from here to here, we call this process derivative, right? And then going from this one, from derivative to a function, then this is called an antiderivative. All right, so from derivative to a function, we call this antiderivative. Or even let's say if we know f prime, from here the f prime is just 2. So again, from here to here we call this derivative, right? And from here to here we call this antiderivative. So basically from f prime we can, as our f double prime, from f double prime we can get f prime taking antiderivative. Okay, and if you want to get f from f double prime, then we have to take antiderivative 2 times, right? So that's what the antiderivative means. So again, to get the antiderivatives, there are certain rules. So let's say a function f of x is equals to x to the power n. This is given. All right, so now we need to take the antiderivative of something which has this expression. Okay, so the antiderivative, the antiderivative of f of x is, of this function is, well, to get, or let's just say antiderivative of x is equals to, so here to take the antiderivative of this kind of expression where n on the power is a number, then in this case we'll be saying that x to the power n plus 1. All right, so this thing n plus 1 is going to be on the power when you take the antiderivative, and on the bottom we will be also getting n plus 1 plus c, or basically you can write any variables or any any variable here. I'm writing c, but well, this c or any variable here is always a constant. So in this case, c is a constant. So basically that means c can be some number, all right? Some number. This can be 0, this can be a negative something. Well, that's why we're saying this is a constant, all right? Okay, then this is rule number 1. Another rule, let's say if we have f of x is equals to something, let's say, again, some constant, in this case, let's say k times x to the power n. Then when we take the antiderivative of this f of x, then again, here we're saying that k is a constant. This constant is multiplied to this expression. And if you're taking the antiderivative of this, then this constant will stay there. And we'll be just taking the antiderivative of x to the power n, which is again this, right? So x to the power n, and x to the power n plus 1 divided by n plus 1 and plus some constant. All right, so whenever you're taking antiderivative, make sure you write this constant here. Okay. Now, what about a function is again given f of x is equals to some number, where k is again constant. Okay, and you're taking the antiderivative of a constant. All right, so antiderivative of this f of x here is, okay, if there is just a number, well, if there's a variable on the bottom, or if there is a variable on the bottom with some number on the power, then we use this rule, right? But here, this is, we are assuming that k is a constant. So in this case, when you're taking the antiderivative of a constant, it is always that number, that constant, k, times x, because we are saying that this function is in terms of x, so k times x. If there is some other number, let's say if there is y here, or something, let's say p here, f of p, then here this should have been p. All right, but since we're saying here f of x, so k times x plus, again, constant. Okay, so these are some rules. So let's do an example. So let's say f of x is equals to 3, or x to the power 3. Then if you're taking the antiderivative of this, so then antiderivative, let me just write der, antiderivative of f of x is equals to, so something like this. This is similar to this rule number 1, right? So then in this case, it's x to the power 3 plus 1, divide whole thing by, again, 3 plus 1 plus c, which will be x to the power 4 divided by 4 plus c. Okay. Or this is rule number 1, or this is example number 1. Let's say if f of x is equals to 3x squared plus 7, something like this. So in this case, so if you're finding again the antiderivative of antiderivative of f of x, then Okay, so here now we have this one plus, right? So what we're going to do is we're going to take the antiderivative of each of these terms. All right, so plus will stay there. If there is plus, there will be plus. If there is a minus, there will be minus. So what we got to do here is, okay, so this is, okay, this 3 is, so this terms is basically similar to the second rule, right? So here 3 will stay there, and we're just taking the antiderivative of x squared, which will be x to the power 2 plus 1 divided by 2 plus 1, which is basically, we can directly write 3, 2 plus 1, 3, okay, plus, now the antiderivative of number 7 is, well, that number times, well, since this function is in terms of x, so 7 times x. Okay, so this rule is the third rule, this one. Okay, okay, so from here, so this 3 and this 3 is gone, so x to the power, okay, one more thing I forgot. So here after this, there should be plus constant, right? And then, yeah, these two are gone, 3 and 3, so x to the power 3 plus 7x plus c. Okay. So when you're taking the antiderivative of the equation, something like this, okay, this is how you do. But what about when you're taking the antiderivative of uh, some trig function? Okay, let's say the function, or which is f of x, is in this column, and the antiderivative of that function that is in this column. So now let's say if you're taking the antiderivative of cosine x, then we say this is sine x. Or yeah, from here to here, we call this antiderivative, right? And if we have something like this, and from this to this, we call derivative, right? So if you're taking the derivative of sine x, we get cosine x, right? So this is just basically the opposite way, you know? So whatever I did in the derivative, so it's just that we are going now in the opposite direction, okay? Um, uh, let's say if f of x is sine x, then the antiderivative of sine x is negative cosine x. Similarly, if say secant square x is given, then the antiderivative of this is tan x, or secant x times tan x is given, and if you're taking the antiderivative of this kind of term, then we get secant x. Okay, so make sure you know some of these as well. So later on some of the chapters, we will be using these kind of rule or these kind of fact. We can take this as a fact, the rules I saw here. You can take these as a fact, and we will be using this on other chapters or other sections later on. Okay. So based on this, let's do a few examples. This section is pretty short section. Okay. So let me do 1 or 2 examples, and then we'll be done. All right. So the first one, let's do the first example here. Let's say if f prime of x is given, which is x times square root of x, and then we need to find f of x. Okay, we need to find this. F prime of x is given, and we need to find f of x. So how do we get from here to here? So this is basically whatever I explained on the first slide. So going from f of x from f prime of x, then we're taking antiderivative, right? So simple as that. So here, okay, so now we have 2 terms or 2 variables here, right? X and square root of x. But what we can do here with this is basically this is x times square root of x, right? So what we can do here is x times, we can write this square root of x as x to the power 1/2, right? And then, well, with this, well, the power of this one, we can also write 1, right? So x to the power 1 is still x. And then now, since these two has same base, and these two, well, we're multiplying these two, so in this case we can just combine this to a single variable and just add the power, right? So 1 plus 1/2, which is also x to the power 1 plus 1/2 is 3/2. Okay, now so basically now f prime of x is also this. Now when we take the antiderivative of this, so n are obviously the antiderivative of f prime of x is f of x. Okay, so f of x is equals to, which is antiderivative of this, is x to the power. So whatever we have on the power, in this case we have 3/2 plus 1 over 3/2 plus 1, and after this plus constant, right? And then this is equals to, okay, x to the power 3/2 plus 1 is, well, it's gonna be 2, 3, 5/2 over 5/2 plus c, or f of x is this, is equals to, okay, so now this 2 is going to go to the top, 5 is still going to be on the bottom, x to the power 5/2 plus c. Okay, so yeah, this is how you do it. Let me do one more example. So if f double prime of x is given 6x squared plus 3x, then what is f of x? So now f double prime is given. So in this case, we need to take the antiderivative 2 times, right? So from here, the first one, when you take the antiderivative of f prime, then it will be f double prime, antiderivative of f double prime will be f prime, right? Which will be, okay, so when you take the antiderivative of this one, so okay, so there is this number is multiplied to this, so the number will stay there, and we'll be just taking the antiderivative of x squared, which is x to the power 2 plus 1 is 3, divided by 2 plus 1 is 3, right? Plus, again, this will stay there, and the antiderivative of x is x to the power 1. There is always 1 on the power, right? If there is nothing, then there is always 1. So x to the power 1 plus 1 is 2, divided by 1 plus 1 is 2. Okay, now here 6/3 is also 2, x to the power 3 plus 3/2 x squared. Okay, so this is f prime. Okay, so we're taking antiderivative, so we get antiderivative f double prime, so we get f prime, right? So now out from this, now when we take the antiderivative of f prime, then we get fx, right? So f of x is, again, 2 will stay there, and when you take the antiderivative of x to the power 3, then this will be x to the power 3 plus 1 is 4, over 3 plus 1 is 4, plus 3/2 is x to the power 2 plus 1 is 3, divided by 3. Oh, one more thing. Here, when we take the antiderivative of this f double prime, then here we get this, but I forgot to write c, constant, right? And now after this, we are taking the antiderivative of this f prime. So antiderivative of this f prime will be f of x. So basically, we are taking the antiderivative of this whole thing. right? So that means we need to take the antiderivative of this constant as well. So if I take the antiderivative of a constant, then this will be, what did I say here? If you're taking the antiderivative of a constant, then it will be that constant times x plus another constant, right? So here what we can do is, okay, so we are taking the antiderivative constant, which will be c times x plus another constant. We can say another variable, let's just say d. Okay, so d is also constant. So here we can cancel a few things. So 2 over 4 is 1 over 2. So 1/2 x to the power 4 plus 3 and 3, these two are gone. So x to the power 3 over 2 plus cx plus d. All right. Okay, so this is how we find, or how we use the antiderivative rules. All right, so yeah, this is basically what it talks on section 3.9, basic introduction of antiderivative. And from next section, well, the next one is 4.1. Okay, so I will be talking more about antiderivative. So antiderivative, okay, so antiderivative is also called is basically, it is also same as integration. So these two terms has the same meaning. Okay, so we can say antiderivative or integration as well. Okay, and one more thing. So I have emailed you guys the exam 2 review, right? Or if you didn't get my email, I have also posted that here. If you go to this course, and if you go to the information, so if you click on the information, then you can see the exam 2 tab here. And if you just click here, you can see the exam 2 review from there as well. Okay, you just have to click here on the information tab. All right, so yeah, that's all I have for this lecture. This is Monday lecture. Okay, I will be again posting another video for Tuesday lecture. All right, okay, thank you so much. I'll see you in the next video.